Hey, hello everyone. Uh, Welcome to today's session on integrating FlightGear with Apache Ignite for real-time in-flight data analysis. Uh, my name is Satej Saw and I work in the role of the principal data engineer at Zalando. In today's session, we'll focus on a few aspects, particularly around simulation, uh, the importance of simulation in the aerospace industry, and how FlightGear as a software application helps us here, and also the need of real-time data in the aviation industry. And then we'll touch base upon the use case, which we will be focusing here in terms of uniting Apache Ignite as a data storing engine with FlightGear, and focus upon how do we analyze this data. We also focus upon the architecture layer, and after that we demo a very short use case based on this. I think that's the whole agenda of this session. The very first case is the importance of simulation in the aerospace industry. Aerospace industry is a very dynamic space with a lot of moving parts, and we understand the criticality of this particular sector because now if you see all these different points here, which I'll go through one by one. The very first is the cost efficiency. When we're focusing in the aerospace industry in particular, there's a lot of cost given that it uses a lot of parts, electricity components, and various other components to build a particular aircraft and then test it out. Now, when we talk about simulation, it really helps in terms of the reducing this cost expenses. The second part is the safety. Now, we can always test, there's a lot of cost when you test a particular aircraft and different flight parameters or environments, but again there is a security part to it, and simulation really helps us in terms of seeing a very risk-free failure testing mode. The third part is simulation is really very helpful in terms of pilot training. When you have different models of aircraft coming up, uh, we don't need a real aircraft to test it out. We can have a simulation environment of that aircraft in flight. You are very similar simulation environments and have the training completed in real time. The fourth is the factor of innovation. So we can always build new aircraft design and some CAD operation or some modeling software and then build it out. But the cost is huge in terms of seeing the performance of that particular aircraft and how does it suit our particular needs in different environments like military, commercial, etc. This is where simulation can be really uh, important in terms of the flexibility to test new aircraft designs, given that we have the same number of parameters and model to test it out, giving a very comparative view of different aircrafts, how it was performing before and also in different environments and different weather conditions. And the fifth parameter is it really allows us to focus on the digital twin aspect of it, where we can get real-time performance analysis of the different parameters, which allows us to do kind of a continuous monitoring and also focus on different aspects, kind of data analysis, machine learning, to focus on kind of monitor it and also focus on some of the optimization parameters when we think about how do we connect with this simulated model and give it feedback, because I think real time data is very important when it comes to the aerospace industry. Moving on to the next slide, uh, I want to talk about FlightGear here. Uh, if you have been an aerospace enthusiast, many of you would have gotten some chance in some mode to play a simulated environment, maybe an Xbox, like use a Microsoft Flight Simulator, maybe have driven a different aircraft models there. FlightGear is very similar. It is an open source flight simulator, and in such you can, the the open source environment have created a lot of uh, aircraft which can be just imported and tried it out in the flight simulator. The second aspect is while trying FlightGear, the advantage of it is that it can provide you with real-time flight data, particularly like the speed, altitude, and also different other APIs like the local environment, the temperature, the wind speed, etc. And it's very customizable with APIs for external integration, like including some machine learning, artificial intelligence, etc. There are also alternatives to it, like X-Plane, Microsoft Flight Simulator, and others. But one of the other things is they're proprietary. You need a license for it. And so always there is a trade-off here. In this particular environment or demo, we'll be focusing on FlightGear because it's very flexible in terms of integration, and there's an open source Python module which helps us to kind of connect with the data elements which FlightGear has. That is very helpful for us to start on this use case to prototype. Here we focus now on the aviation industry's need for real-time data. If you consider different industries, like you can talk about e-commerce, and maybe the any other industry, we can tolerate a level of lag in terms of the trade-off parameters, like how soon do we need data? Because I think in the aerospace industry, there's a lot of importance in terms of how it's a matter of life and death in terms of how important and critical uh, the environment is, because there are a lot of dynamic factors in the air which needs to be monitored in terms of the feedback which we receive from the air traffic controller, in terms of how do we manage the environment in terms of interaction with other aircraft which might be flying in the same route, and also in terms of thinking uh, the different parameters which might be needed for a on the ground controller to monitor or see the real time path of the aircraft. So here we focus upon these 4 points, particularly the importance of real time monitoring, where we want at any time to monitor how our aircraft is performing, not only during development and training of the particular aircraft, but also later in the real time use when it is actually flying different users and customers on the air. The second is the safety enhancements through continuous analysis. When we talk about real time data, anything can change because a particular part could fail, a particular environmental change can be done. So this simulation really helps in terms of how do we change these different parameters and see how our aircraft is reacting to it. Because when you consider a digital twin which might be operated in a system on the ground, this will give you real-time data in terms of in analyzing without actually being on the aircraft, giving you opportunity to change some real-time values which will help not only to assist the pilot on board, but also see how the aircraft has been performing. The third is operations in terms of operational efficiency improvements. This really helps because when you're collecting all this data from a simulated environment, it gives you a very huge set of data which can be used for your analysis, seeing the performance improvements over time, and comparing it with other aircrafts, and also using that data for machine learning use cases to further assist your pilots or your aircraft environments as a digital assistant. And the very fourth parameter is the collection of different parameters, because these are all very important in terms of what we are collecting, and this is very relevant to the use case which we are trying to drive here. Every application which you're building has different use cases, And using simulation really helps open source researchers uh, to build different contextual applications. UI focuses specifically user experience and various other setups. So this really depends on your use case in terms of what you're trying to achieve it. The use case which we will be talking in today's session is we have FlightGear, which is kind of a software application which is simulated based, where we will drive a particular aircraft, which would be the Cessna simple model of aircraft. And basically, whenever it is flying, there are different parameters which this flight is capturing in terms of the speed, the temperature of the oil which it's storing, the altitude of the flight, and how this data can be stored, because we want this data to be stored somewhere so that this can later be used for operational data analysis, for machine learning use cases. Now, the l- other aspect here is that this can be very simple enough, it looks simple enough, but the most important factor is how do we scale this? Because we can set this up in a very small environment, but how about on an enterprise level when organizations want to focus upon different aspects, because time is a very important factor when you're spending time on building an application. You want data on a parallel level because you don't want to test flight just on a single machine. We want to test the same application on different aircrafts. So starting and spanning these flight gears across different instances in the cloud, and how do you process this data on this big data level? So I think that's very important, and that is where we need to focus upon. Now, when you talk about the simple use case layer, we can think about the data storage layer. Could be many aspects. Nowadays, we have a plethora of databases which support us in this particular criteria or scope. Now, here we talk about why Apache Ignite really shines in terms of the data storage layer. And whenever any choice of application tooling for any use case, it all depends on a trade off. It's not a right or wrong decision. Basically, what helps you and why, being kind of an architectural decision record. Here, if you see, we are touching upon three kind of databases or storage layers here. First, focusing upon Amazon S3 and RDBMS, and then Apache Ignite. These three, if you think about, mm, are separated into three layers, or three scope elements. The very first being a file storage, the second being a relational database, and third Apache Ignite being a scalable memory based storage with a uh, reliable back storage, which you can be S3, it can be Cassandra, with a plethora of options there. Now, when we start upon, let's say, uh, with Amazon S3 in particular, it is storage focused because it's scalable. You can store a lot of files there. The second aspect is that it is slow data retrieval because it has a lot of uh, tiers in terms of the standard, kind of availability, zone based, local based, or kind of archival glacier. But again, it spans to a slow data. It's not meant for a fast data retrieval. And there's no real-time querying because it's again relevant to the slow data part, with having batch collection modes and with eventual consistency. And there's always a wait time in terms of where you're storing and making it consistent across different availability zones. The fourth is it's kind of a simple data storage. We can store it in different complex formats, but it makes it simple enough to store files in different formats. The second part now, if we focus upon, is relational databases. These are more disk I/O based because eventually you're processing something, you're saving it to the data into the disk and fetching it back. And they really have their scaling challenges because when you want to scale it in terms of both data schema and how you evolve it, and also in terms of how you're scaling it in terms of different machines, right? And one of the challenges has been that they're always vertically you can scale them, um, and it also relates to how complex the fault tolerance is because if one particular node fails, how do you move to the others and in a scalable manner? That has not been very flexible enough in the real world use cases that we have seen, and they're really not meant for real time analytics. They're good for transactional environments, but not so good enough for very real time analysis. And they have limited event processing in terms of what you can achieve out of it. And now, focusing on the second part here, where we come to now the Apache Ignite part, both RDBMS and Apache Ignite are very good enough for asset compliance. And this is where now we focus on, if you see on the Apache Ignite part, some of the features which are very relevant to our use case, and particularly in the aerospace industry, is the low latency, which we are seeing is very important because it's now more memory driven. And one could always argue that we could use any other memory based storage to make it low latent. But again, we want to be cost effective. That's where the scalable part comes in terms of the horizontal scalability using very cheap commodity hardware and also make it scalable on the cloud in different environments, particularly like make it easy to instance based or ECS or Kubernetes, etc. And the other part is the fault tolerance. You also see this scalable and fault tolerance in Amazon S3 too, but not combined with the asset compliance and low latency features. And the other features then come down to the real-time analytics, where you are not only able to save real-time data, but also use this real-time data to get the data back in terms of any use cases like inference and machine learning or kind of do real-time dashboarding. This is very important in terms of gathering feedback, taking analysis, and showing this data back to the maybe to the pilot or to the ATC on the ground, so that they can take action on this particular. And one of the other factors which Apache Ignite really shines is the advanced caching and the different patterns, because it does not limit itself to only a single pattern where you're just storing. It also allows you to sync data up, have different nodes in parallel where you can run it across, have your data be partition aware, so that it's not only shines on a single node, but also based on the CAP theorem, you can switch between different modes based on your transactional or non-transactional modes to achieve different levels of scope when you're trying to use Apache. And last point which I wanted to touch base here is the complex data types where Amazon S3 can store it, but again, the slow data retrieval, it can store your data in different formats like maybe Delta Lake, Apache Iceberg, etc. But that is more on the big data level. RDBMS also is now gaining some capability in terms of storing some hash map or JSON values. But again, there's a lot of, I could say, change in terms of the encoding by switching from binary to JSON, and the processing really takes time. This is where the complex data types and Apache Ignite is very helpful in terms because it takes this consideration in terms of making it fast enough because you can not only store binary data type but also store managing it with different languages like Java or Python, store it in a class format which helps you to test your environment, but also store it in this compliant format in the database. So now coming to the architecture part, this is the model which we'll be touching base today. If you see here, the very first part, when we focus on the use case, there was FlightGear. Then we had Apache Ignite and the visualization part. Now this is more about how do we scale it. When you scale it about, you can scale it in different environments, particularly in a serverless environment, because FlightGear you can run it in the UI mode. And this can be different environments, particularly because FlightGear runs in all operating systems, particularly Mac OS, Windows, and Linux. So making it very flexible enough where you want to host it. Once you have these environments, uh, FlightGear Python is a Python package which connects with FlightGear to enable you to collect this data. So all these instances will have a Python module installed so that it can connect with your FlightGear instance and collect this data in real time. Once you have this setup on the left where you have different instances being fired up or created, on this, the second requirement is the collection of state data because it's very important for us to collect all this data. And this is where we are streaming the data through the PyIgnite package of Python, which connects with Apache Ignite. This feeds the data into the Ignite pods. When you talk about Ignite pod, in this particular instance, it is a Kubernetes pod, and we can scale it across by using a deployment parameter. Using the different addresses, if you see the service discovery mechanism, where it can collect all these address points of all the pods, and this enables FlightGear Python module to connect with any of the pods or any of the instances if we are choosing EC2 as the deployment environment to connect with that because internally the cluster is connected and they know where all the different pods or the instances are available, allowing them to be partition aware and syncing the data based on the different replication parameters which might be used, making it very scalable, partition aware, focusing on the cap theorem because cap theorem always allows us to, uh, in a practical manner, any two scope area based on consistency, availability, or partition aware. And once we have this, because storage is important, but it becomes irrelevant if you're not able to actually use the data. This is where now in the third part, we have a dashboard visualization. It can be anything because you can connect based on different ODBC environments to Apache Ignite and run your SQL queries or connect it through different thin clients like Python, Java, etc. and get this data to Power BI Tableau. But in this particular demo, we'll be connecting with um, a different other environment, particularly Streamlit, which is a dashboarding environment in the Python environment, very easy enough to start with. Coming to the code setup, there are three particular parts here. First is we need to install FlightGear, and there are some references which will be later shared as to where you can get it from. Being open source, you can just download FlightGear, and once it is, and this particular I'm showing it on a Linux environment where you can download an app image and then start your FlightGear. That's the very first that we get a instance of FlightGear started. The second part is to set up a Python environment where we install FlightGear Python, which is a package which is used to connect to FlightGear. The second is PyIgnite, because once we connect and collect the data from FlightGear, we need to send it to PyIgnite, Apache Ignite. And PyIgnite is a Python thin client which allows us to do that. The third part is Streamlit, because once we have the data in Apache Ignite, we want to collect it and show it in real time in terms of how the data is changing. in terms of very simple prototype. Once we have this setup, you can modify that to different other use cases as you see feasible and change it accordingly. If you see the second block here, where we are starting the flight here through a command line terminal, there are two options, and the most important part is the telnet option because that is the interface which allows FlightGear Python to connect to. So it basically opens a telnet socket on the port 5500 with 60 being the frame rate at which you are changing, which should be good enough. And the protocol is TCP through which FlightGear will connect with FlightGear Python module will connect to FlightGear. Now, once this is done, you have the instance setup. The next part is just some basic code here. The very first being importing some of the packages which will help us to connect to FlightGear and Apache Ignite. So if you see here, we are importing FlightGear Python and PyIgnite. FlightGear Python allows you to connect to using FDM and both Telnet, but FDM is a bit more resource intensive. You can always check out the documentation to see which helps you more. For this use case and demo in particular, I've chosen to go with uh, Telnet because it's very quick enough and I think it's very less resource intensive in terms because it's very important in terms of what you're trying to achieve through this particular scope. The second part now is that we create a cache here called flight data cache in Ignite, and we are using it or create cache so that if it's already present, we're just getting a connection to it. And the second part is we also need to establish a connection to FlightGear. That's how we are connecting through the telnet connection and ultimately calling the connect method. So there are two parts now. We have set up the Ignite application, FlightGear instance. Now we have connected to it. The third is how do we get different parameters. Always when you click on the telnet connection, if you see telnet con.getprop, this allows you to see particular directories because that's how it stores different parameters. If you are connecting with engines and engine and you want a various some other parameter for engine, you can just change that parameter there. And we are now focusing on three particular elements here, where we are thinking if the engine is running, what is the altitude at which the aircraft is flying, and the oil temperature, because it's important that our engine is tolerating the temperature in different environment. And we collected. The most important part here is if you see the data type which we are storing with a timestamp, because we want to analyze how these different values are changing over time. This is where we are putting now the value that is a timestamp and the type ID, which is very important, where it's a hash map value. And if you see here, I think in the code, there's a hash map which we import, particularly which is really relevant in terms of how you are showcasing it. I also showcase a bit of the code while I'm demoing it. This is where, and we're collecting this on a interval of 1 second to fetch this information. You can also tune it in terms of how fast you want and what particular intervals. And one other particular aspect is I think there's a list props environment, and you can just give a slash, and it will give you from the telnet connection the different properties which are available. Because it's not only about position engines, it's also about your local environment, along with you can say the wind, in which location, in which altitude. Because it's if you think about it, you can build a variety of applications because that's where the dynamic environment of aerospace really uh, could be a challenge, and at the same time, it could also be an opportunity to better provide different scopes which help us to tackle these challenges, providing scope for and opportunity for different applications. Now that we are at this part, I'll quickly start up environment and showcase you a very quick demo as to how the environment looks in terms of giving you a very quick peek into the FlightGear application, which will show you a Cessna model flying in the sky, and then we collecting this data, showing you some of these data points, and ultimately collecting this data and showing you a real-time dashboard, which you can adapt and change it as per your requirement. So now everyone can see that we have in the flight mode here, and kind of flying on a very safe journey here. And let's increase the speed of our flight a bit so that we can see it here. Now here, if you can see, we'll connect to our data points here. And if you see, it's pinging right now, right? Oil temperature, altitude, and the engine is running. So it's giving us some viewpoints here in terms of how we are collecting. And now, if you also see, we on the real time, we are collecting data in the dashboard, which, if you see, kind of is comparable. And now if I change the flight, we can in real time see the data in terms of how it is being collected from Apache Ignite. And that's how it's very important because I think it gives us real time data in terms of how we are changing it and how we are tracking our speed and height uh, eventually. So this is how you can see this just we are touching the surface here in terms of the different parameters which we are collecting. But now you can see how the flight because the temperature is not that fluctuating. If you see in the data points here, kind of 1 or 2 degree Fahrenheit changing. But if you see the flight, we have a lot of variation. And similarly, you can capture different other parameters, make it flexible enough for your kind of the scope of the application which you're trying to build, and eventually kind of report on these parameters. Now that we have touched base upon this basic small use case, I'll also touch base upon the code which we are writing here, because I think it's very similar in terms of what we touched base upon. The only other element is this type ID, which is the map object of mm, flight here, which helps you to touch base upon it. Now I think we are going too low. Maybe we can increase the height a bit so that we don't crash here. And we'll just increase the height a bit. We are too low here. And here, okay, we are not able to, yeah. Perfect. This is, the just the demo which I wanted to showcase here. Now, with this happening, on here, once the code here, if you see how this is a very important because ours is a complex data type, and we want to use a LinkedIn hash map, which helps us to store in this particular format. And here is a Streamlit application that you see is kind of it's capturing the 100 back keys in terms of the timestamp, and basically reiterating over it. And you can adapt it, you can change it and modify it so that you can display different, because here basically we're displaying the oil temperature and the altitude here in terms of how the values are changing. So I hope this demo was helpful in terms of, because this is not only essential for, you know, in terms of enterprise, but a really intuitive environment in terms of how you can play with it, build and work on research stuff in terms of how you want to utilize this value, because sometimes it's very difficult to get, data when we are interested in building these applications? And how do you touch base upon it? Because real time is important and the values are also important. So these two different environments, when connected together, really helps you uh, to evolve this layout and build different kinds of applications out of it. And it all depends upon your use case. These are some of the references which you can follow up with to see what the actual code looks like in GitHub, and also the blog in terms of just reviewing the some basic documentation in terms of how you can start stepwise, and also where you can download FlightGear, and also the FlightGear Python package and PyIgnite thin flight documentation to help you further learn on this. Uh, and this is a very short intro related to my bio in terms of the two books which are written, and I think due to the kindness of Appress Publication, they have shared a 20% discount code for all the attendees of Ignite 2025 conference, which you can use it to buy these books if it's of interest to you. And you can also follow up with me on my blog, GitHub, and LinkedIn and YouTube if you want to further connect with me relevant to any questions or any future scenarios which you see opportunity for. So I think hopefully this session was helpful to all of you in terms of understanding a brief use case in the aerospace industry connecting FlightGear. You can replace FlightGear with any other modules or simulation environments, particularly like Microsoft Flight Simulator and others. Every one of them have their developer interfaces to connect data points. The key point is how do you connect it to a centrally available, very easily scalable, uh, memory-based solution, because we can eventually store this data in S3 too by connecting it with Apache Ignite. But the real use case is the real-time based data in terms of how do we react to it and use it proactively. And with this, I leave the stage for some question and answer session. Thank you.